Okay, now coming to motor aspect of communication. Motor aspect of communication. So broadly, we can say this process of the speech, whatever we are speaking, it can be divided into two parts. One is like, say, whenever we say anything, speak out any word, any sentence, anything to a person when we are in a conversation with the other person. First and foremost, there will be formation of thought, right? Like what we are supposed to say. Formation of thought to be expressed. That is the one part. And what is the other part? The other part is, along with this formation of thought to be expressed, along with there will be the choice of the words. See, if you want to say anything, there can be so many words for that. So the choice of the word and the formation of thought to be expressed, that is the one part. Second is motor control of vocalization or articulation, right? The motor control of articulation plus last part will be articulation itself, like that motor part of the articulation, that is motor control is via the primary motor cortex area, right? The primary motor cortex area. And articulation, ultimately the effective articulation, you will speak out that phrase or that part of the conversation, right? So the formation of this thought and formation of the thought as well as the choice of the word, this is the function of sensory association area. This is the function of sensory association area of brain. And what is that particular sensory association area? That's the vernix area. So vernix area, again this vernix area plays the important role for the formation of the thought to be expressed and the choice of the words. And this thing will be conveyed via the arcuate fasciculus to the Broca's area, right? To the Broca's area. Now these thoughts that are to be communicated, they will go and reach over to the Broca's area, and from the Broca's area this motor control of articulation and articulation itself will happen, that second part. So we can say, if there is a lesion in the vernix area or that arcuate fasciculus, if there is a lesion in the vernix area or the arcuate fasciculus, then that person won't be able to formulate the thought, or that part of the speech what is to be spoken. And to put together the sequence of those thoughts, that will happen in the lesion of the vernix and the arcuate fasciculus. Now if that person has got, say, let's talk about something about this Broca's area. If that person has lesion in the Broca's area, and this Broca's area, that person won't be able, if there is a lesion, won't be able to speak out the words or emit the words or speak out the words. So that person won't be able to say the words, or if he says at all, then that won't make any fluency. There will be non-fluent speech, right? The non-fluent speech will be there. Therefore we can say the Broca's area is important in expressing or speaking out the words of the formation of that thought that happened in the vernix area, and you have chosen your words, like what is to be spoken, that will be conveyed with the help of the Broca's area to the motor and the premotor area. So if there happens to be any lesion in the Broca's area, that person won't be able to speak out the words, though he has, we can say, he has prepared his thought. He knows what to speak. He has chosen his words, what to speak, but still not able to convey. So what it will make? It will make the person very frustrated. He is aware about his problem. He is aware about his problem. So that's regarding the Broca's area. So depending on, like, say, which part is getting affected, whether it is the Wernicke's area is getting affected, or the Broca's area is getting affected, or in between that communicating part, the conduction part, that bridge, that is the arcuate fasciculus, there will be different type of the aphasia, and they will have different symptoms. So those different symptoms, one by one we will cover. First of all, aphasia, it happens if there is the problem in the categorical hemisphere, or dominant we call it, right? That is most of the times it is the left cerebral hemisphere. So aphasia is loss of or defective language. Aphasia is loss, or either the loss or the defective language from the damage to the speech center within the left cerebral hemisphere. Please note, in aphasia there is no damage to the vision, there is no damage to the hearing or the motor paralysis. The damage is in speech center, right? In the speech center. So how will we, if you ask a person to define the aphasia, what is the proper definition? The proper definition is, aphasia is higher order language deficit. Higher order language deficit. And what do you mean by higher order language deficit? It is inability. It is inability to either the understand or produce or use language appropriately. That is the definition of the aphasia. Means we can say aphasia is higher order language deficit. It is inability to either understand or produce or use the language appropriately, and it is caused by pathology in dominant or the categorical cerebral hemisphere, that is usually the left side. Now, if there is aphasia, there is one more thing, one more term, that's called as dysarthria. What is dysarthria? Dysarthria is, this is motor inability. This is motor inability to produce speech. So in dysarthria, these speech centers are not getting affected. The motor part, we can say from motor, premotor area, from there onwards there will be deficiency, or we can say the movement deficit will be there in the case of the dysarthria, right? So in these different type of the aphasia, it can be either the expressive one or it can be the receptive one, or the receptive is sensory and expressive is motor. So if different areas are affected, then what kind of the defect will be there? Say if there is involvement of Broca's area, it's not falling under the receptive, this is deceptive, forget about this one, this part, let me rub it off. Okay, now if the Broca's area is getting affected, what is happening with the person? The speech will be non-fluent, right? Understanding will be normal, but the voice production, it will be defective. So it will make the person aware, the person is aware about his defect, so it will make him or her very frustrated, as well as there will be the good comprehension. Because that comprehending part, Wernicke's area, that is functioning normally. Now in the case of the Wernicke's area involvement or the conduction aphasia, in both of these situations the speech will be fluent means he will be speaking very fluently, but it will be the meaningless words or with loss of comprehension or understanding, because this understanding part is defective but speaking part is normal. That's why the fluency will be maintained, but it will be meaningless words, or we can call it word salad. There will be kind of a word salad. Like जैसे आप जाते हो शादी में तो सलाद खाते हो तो हर तरह के होते हैं ना वहाँ पे एक मिक्स किए हुए, तो देयर विल बी द मिक्सिंग ऑफ द वर्ड्स. सो दैट इज very easy to remember word salad in the case of the this vernix aphasia. Now, if only the angular gyrus is getting affected, there is a lesion of the angular gyrus, then that person won't be able to name the object by looking at it. Anomic aphasia, unable to name the object. And if there happens to be the widespread damage to the speech area, that is global aphasia. Mixture of all these things will be there. So we can say if the auditory association areas are affected, there will be the word deafness. If the visual association areas are getting affected, there is word blindness. That is called as dyslexia, right? Dyslexia. The patient cannot interpret the meaning of the words by looking at them, right? Vernix aphasia is unable to interpret thought. The receptive or sensory aphasia. Broca's area, there will be the motor aphasia or expressive aphasia. There will be non-fluent speech, and in the case of the global, it will be mixture of both, unable to interpret the thought plus motor aphasia. There is one very good diagram, this diagram. Just mug it up, this 2x2 table, and it will answer all the questions. Before going to this part, before going to this 2x2 table, there are few of the words like transcortical. So let me tell you something about this transcortical sensory, transcortical motor, and transcortical mixed aphasia. First of all, the transcortical motor aphasia means the person's entire frontal lobe is getting affected except the Broca's area, except the Broca's area in the case of the motor aphasia, transcortical motor. And in the case of the transcortical sensory, the entire temporal lobe is getting affected, but vernix area is working fine, right? And in the case of the transcortical motor aphasia, entire frontal lobe is getting affected, but Broca's area is working perfectly fine. Now the transcortical mixed, it means both the vernix and both the Broca's and vernix area, as well as the communication part between them. What is that? Arcuate fasciculus. All the three things are working normally, but the surrounding area of the temporal lobe and the frontal lobe, it's getting affected. That is called as transcortical mixed aphasia. So now if we see at all these things, see in this 2x2 table, first and foremost is comprehension. This part, this falling under this line, they have got the good comprehension. So who has got the good comprehension? In the person who has got the good comprehension, the function of the which area is for the comprehension? Vernix area. It means that person will be having very good vernix area. It means it will fall under the motor part. So Broca's area will have good comprehension. The transcortical motor aphasia will also have the good comprehension, and the conduction aphasia will also have the good comprehension, because in the case of the conduction aphasia, vernix area is functioning normally. From the vernix area it goes to the Broca's area. So from this point onward there is a lesion, and this area, before this area, this vernix, it is for the comprehension. So comprehension is fine. Now the poor comprehension is falling for these vernix area, the transcortical sensory area, the transcortical sensory aphasia, and transcortical mixed aphasia. That is the one demarcation how to divide these into like 2 by 2 table, comprehension, good comprehension and the poor comprehension. Now the second part is fluent speech or non-fluent speech. Fluent speech will be present in conduction aphasia, vernix aphasia and transcortical sensory aphasia, right? And non-fluent speech or the fluency will be affected in Broca's aphasia, transcortical motor aphasia and transcortical mixed aphasia. So one point is comprehension. So if sometimes they ask the question, write the difference between the Broca's and vernix aphasia, then first point will be like Broca's aphasia, Broca's area is getting affected, and vernix aphasia, vernix area is getting affected. You can write down one point. The second one is regarding the comprehension, good comprehension and poor comprehension. The third one will be regarding the fluency of the speech, fluent speech in vernix, non-fluent speech in Broca's. Now there will be one more point, that is repetition. If we look over here from above this line onwards, say this part, it has got poor repetition of the words. So in the Broca's aphasia, in the vernix aphasia as well as the conduction aphasia, all these three aphasia, they have got poor repetition. And the remaining these three, the transcortical motor as well as the transcortical sensory as well as the transcortical mixed, all the transcortical aphasias, whether the motor, mixed or sensory, they have got good repetition. Why? Because in all these three, the Broca's area, vernix area and arcuate fasciculus all are working perfectly fine, but the surrounding part is lesioned, right? Then the repetition won't get affected. This faculty is working normally. So that is all regarding these